Hello and welcome back to Geometry. We are in chapter 11 now, section 1. We're staying with circles. We're looking at circumference and arc length. Remember that circumference was related to the diameter. We had a ratio, that's pi, and pi was a ratio of the diameter to the circumference. So circumference, recall, was pi times the diameter, and since the diameter is 2 times the radius, we can write circumference is 2 pi r. Okay, so that's not news, just bringing this back to your mind. Now, here we have the radius. Okay, the circumference is all the way around the circle. Now, if I cut off a part of that circle. Oh, that was terrible. We're going to do that again. Here we go. This part right here. Okay. I want to find this part right here. It is called an arc. Okay. Now that arc is related to the angle in here. Let's say the entire circumference of this circle is 120 centimeters. Okay, now think about it. Pause the video and see whether you can figure out how long this arc is. And if you said that arc is 30 centimeters, you would be correct. So the measure of the arc, let's call this circle C, this will be A and B. So the measure of arc AB is 30 centimeters. Centimeters. Okay, how did we get that? Well, you would know that this is a fourth, right? This is 1/4 of the entire circle. 1/4 of the pi, right? And this is because this is 90 degrees. How do we know that that's 1/4? Because we do 90 over 360. So I can take the 120 and multiply by 90 over 360 to get the arc length. Okay? And so that gives us arc length is equal to the circumference times the central angle over 360. Let me redo this. That is the central angle. That angle over 360. All right, so find the arc length of AB. All right, well, the arc length is circumference times the central angle over 360. All right, so the measure of arc AB, arc, is equal to 2 pi times the radius times 60 over 360. Type that in, and you get the measure of arc AB is equal to, I meant to substitute in here for radius. This is 8 right there. Okay, because the radius is 8, so type that in, and you get approximately 8.38 centimeters for this arc. Okay, find the circumference. All right, again, we know that the measure of arc XY is equal to circumference times central angle over 360. All right, now we're looking for the circumference, so we're going to multiply by the reciprocal of this. Let's plug in first, so you don't get quite as confused. 4.19 is equal to central angle times 40 over 360. To get rid of this, I have to multiply each side by its reciprocal. So that's 360 over 40. So 360 over 40. And that cancels out the 40s here, 360s, and then I get the circumference is equal to approximately 37.71 inches. That's the full circumference. All right, here we want the measure of the arc MRS. Oh dear, goodness. Measure, that refers to the degrees, right? That's this right here. Sorry, we have to go back here and erase this. My bad. I was just having too much fun with that. That is the arc length. So that's arc length. Wish there was a letter for that. Arc length and arc length. Go back in your notes, previous page. Here I wrote measure. That's not the measure, that's the arc length. The measure of that arc is 90 degrees. Okay, so that right there should say length. All right, change that in your notes. All right, we all make mistakes. I apologize. We're having too much fun here. So we are looking for this angle right here. Arc length, well, arc length of RS is equal to circumference times angle over 360. All right, so we know the arc length is 44. We can find the circumference. That's 2 times pi times 15.28 times, and now we're looking for this angle right here. So that's the measure of arc RS over 360. Okay, that is terrible. I will rewrite this. All right, there we go. That's a little bit better. Now, divide by 2 pi 15 times 15.28. And that is the measure of RS over 360. Multiply each side by 360. This cancels out. And the measure of the arc, all right, the measure of the arc is the degrees, all right? Remember that. And that's approximately 165 degrees, all right? So arc length versus arc measure. All right, sorry. Notice I made that mistake. Please don't confuse it. Okay, dimensions of a car tire are shown to the nearest foot. How far does the tire travel when it makes 15 revolutions? All right, so first thing we want to find is the diameter. So we're going to add all these. So that is 26. Circumference is 2 pi r or just pi d. So circumference is pi times 26. This is doing 15 revolutions. So we're going to have pi times 26 and then times 15. Okay, because we're going 15 times around. All right. And that is approximately, that's 15, that is approximately 1,225.2. But that is in inches, okay? Notice they gave us all this in inches, but then they want to know feet. Those sneaky sneaksters. So in order to get it in feet, we're going to convert 1225.2. Oops, got a little crazy on the twos there. Making a lot of mistakes today, all right? But it's good when we catch them. Times, we know that 1 foot is 12 inches. So we're going to divide this by 12, and that gives us about 102.1 feet. And they said to the nearest foot, so that's approximately 102 feet. Okay, Now, we're not quite done yet, because we got to talk about radians. All right, now, here's our radius, here's our radius. We measure a circle in 360 degrees, and that's a fairly arbitrary measure. Came from a number system, used 60s, but this right here is basically if we take the radius and measure it along there. So that's 1 radius. Okay, so that's what we call the radians, a radian. How many radian are in the full circumference? Well, we know the circumference is 2 pi r. To figure out how many of these segments fit into that, I have to divide this by that measure, right? And that measure is r. So we get a total of 2 pi radians for 1 full circumference. So 2 pi radians is 360 degrees. All right. Now, you could also simplify this by dividing each side by 2 and say that pi radians are 180 degrees. All right. Now, we're going to use this for some conversions back and forth. If I divide each side here by 180, then I get pi radians over 180 degrees gives me 1. Right? That's 1 full circle. Pi radians over 180, because I started with 2 pi radians over 360. Simplified by the 2, we get over 180. All right? If you want to know a degree, you just multiply by this, which is 1. If you want to know radians to degrees, then we flip that upside down. All right, so 45 to radians. We know 45 degrees times 2 pi r, 2 pi radians is a full circle divided by 360. So we could either write it like this, over 360 times 2 pi radians, because 2 pi radians is a full circle, and that converts to a circle, and this is how much of the circle it is. Or we could rewrite it and just use what we had, the pi radians over 180. Okay, and remember, when you're multiplying, you can make this one long fraction because it's multiplication. Simplify that, and that is approximate. This simplifies down to, we get 4 here and 1 there, and so we get 1 pi radian over 4, or we could rewrite this and say that's pi over 4, pi fourth radians, like this. All right. Now, if we want to go from radians to degrees, I'm going to flip this upside down, and I'll say I'm going to take 3 pi over 2 times 180 degrees over pi radians. Notice how pi will cancel out. We can divide 180 by 2, gives us 90. Simplify those. Times 3 is 270 degrees. There you go. That's converting between radians and degrees. Good times in the Matherhood. Check in again next time for another fun lesson.